Due to its enormous size and luminosity, the red supergiant star Betelgeuse, which is in the Orion constellation, has long captivated astronomers and sky watchers. If Betelgeuse were positioned where our Sun is, it would extend all the way to Jupiter's orbit, showcasing its immense dimensions. Even though it is only 642 light-years away from Earth, its sheer size makes it one of the brightest stars that can be seen with the naked eye. In recent times, however, Betelgeuse has shown some unusual activity, including unexpected dimming and brightening cycles, which many scientists believe may indicate that the star is nearing the end of its life. The renowned physicist Brian Cox recently made a groundbreaking declaration that Betelgeuse is on the verge of a catastrophic explosion, which is anticipated to take place within the next 2 weeks. Betelgeuse's final stage will be marked by a phenomenon known as a supernova, but it will also provide astronomers with an extraordinary opportunity to study one of the most powerful and spectacular phenomena in the universe as a massive star approaches its end. Betelgeuse is classified as a red supergiant, one of the largest and most massive types of stars in the universe. It has been observed for centuries, but recent erratic brightness changes have sparked speculation that it may soon go supernova, as happens when a star like Betelgeuse dies. It explodes massively, releasing an incredible amount of energy, radiation, and stellar material into space as a result of its core collapsing under the immense pressure of its own gravity. It is anticipated that the upcoming explosion of Betelgeuse will be a Type II supernova, a particular kind of stellar detonation that takes place when the core of a massive star collapses. This core collapse initiates the release of neutrinos and radiation, which creates a shock wave that disintegrates the star. The explosion will be so intense that it may even be visible from Earth without the need for telescopes, possibly even outshining the moon in the night sky for several weeks or months. The distance between Betelgeuse and our planet, which is approximately 642 light-years, means that, although the explosion will be dramatic and visible, it will not pose any risk to life on Earth. This kind of event would typically be destructive if it occurred closer to Earth. However, this occurrence promises to alter our perceptions of supernovae and cosmic phenomena. One of the universe's most explosive events, a supernova releases more energy in a short period of time than our Sun does over its entire lifetime. Betelgeuse's explosion will not only be a dazzling celestial display, but also an invaluable scientific event. Researchers are eager to monitor this rare incident from the very beginning, utilizing various ground-based and space-based telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide spectrum of radiation, ranging from visible light to gamma rays. One of the most critical aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that seldom interact with matter. Neutrinos from a supernova can actually arrive on Earth before the light from the explosion itself, due to their ability to pass through nearly everything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving scientists an early start in observing the final moments of Betelgeuse. In addition, the explosion will provide crucial insights into how heavy elements are formed. When stars go supernova, they forge and release elements like iron, gold, silver, and uranium, materials essential for life as we know it. Researchers will be able to observe this element creation process in real time while studying Betelgeuse's supernova, which is essential for comprehending the chemistry of the universe and planets. Although Betelgeuse's supernova is not expected to have harmful consequences for Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, could generate stronger auroras, expanding the regions where the northern and southern lights are visible. Although these cosmic rays might disrupt satellite communications and some Earth-based technologies, any disruptions are likely to be minor and brief. Betelgeuse's explosion will be visible to everyone on Earth for weeks or even months, not just professional astronomers using high-tech equipment, which is one of the most exciting aspects. Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will not only captivate the scientific community, but also engage stargazers and the general public, sparking renewed interest in astronomy and the cosmos. Astronomers have long speculated about the death of Betelgeuse, but Brian Cox's recent statement adds a sense of urgency to the situation in the coming weeks. Every stage of the supernova is being studied by observatories all over the world, and the data that are collected could change our understanding of stellar evolution and the distribution of cosmic matter. Betelgeuse's supernova will also provide a rare opportunity to refine our models of cosmic distances. Being relatively close to Earth, it offers an unparalleled chance to observe how energy from such an explosion travels through space by studying the light and radiation from the supernova. As it interacts with the interstellar medium, the gas and dust that exist between stars, astronomers will gain a clearer picture of the universe's scale. This event will also provide a golden opportunity to investigate dark matter and how it may influence supernovae. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. The behavior of light and matter around Betelgeuse following its explosion, on the other hand, may provide indirect clues about the role that dark matter plays in shaping the universe. Betelgeuse's supernova will also take us closer to understanding the life cycle of stars, especially how massive stars contribute to the creation of the elements necessary for life. Supernova are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even life. By studying Betelgeuse, scientists will obtain crucial data on how these elements are forged and distributed. The explosion of Betelgeuse has a significant cultural impact. For millennia, humans have looked to the stars for guidance, inspiration, and even meaning. The disappearance of one of the most prominent stars in Orion will prompt philosophical reflections on the transient nature of the universe. Betelgeuse has been a constant fixture in the constellation Orion for as long as humanity has observed the stars, and its absence will serve as a powerful reminder of the impermanence of all things. In some cultures, such celestial events have been seen as omens or signs of cosmic change. Betelgeuse's explosion may evoke a mix of awe, fear, and wonder as people from all walks of life witness a star's death. This extraordinary event will likely reignite interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows virtually anyone with a camera or telescope to observe and document the supernova. People from all over the world will be able to observe and record the same cosmic phenomenon from their own unique perspectives as a result of this democratization of science. Not only is the explosion of Betelgeuse a singular astronomical event, but it also serves as a foundation for future space exploration. The knowledge gained from the supernova will influence how we study other stars, especially as we venture deeper into space with missions to other planets and stars. Understanding the life cycles of stars and the dynamics of supernovae is crucial as humanity looks to expand its presence beyond Earth. Additionally, the explosion will reignite interest in the search for extraterrestrial life. Supernovae play a vital role in distributing the elements necessary for life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can gain a better understanding of how the ingredients for life might spread to other planetary systems and potentially spark life elsewhere in the cosmos. The impending explosion of Betelgeuse is shaping up to be one of the most significant astronomical events in our time. Its supernova will provide a wealth of scientific data, enhance our understanding of the universe, and captivate people worldwide. Though Betelgeuse's death will mark the end of a giant star, it will also symbolize the ongoing cycle of creation and destruction that governs the cosmos, a reminder that from death, new stars, planets, and even life can emerge. As we await this monumental event, the world will be watching the night sky, anticipating the moment when one of the universe's most powerful forces bursts into view. For both scientists and stargazers, Betelgeuse's final act will be nothing short of awe-inspiring as Betelgeuse approaches the final stage of its life. Its potential to shed light on dark matter and dark energy, two of the universe's greatest mysteries, is one of the more speculative but intriguing possibilities surrounding its impending explosion. It is believed that the vast majority of the mass and energy in the universe are caused by these elusive forces, yet they remain poorly understood. Some scientists think that supernovae, like the one in Betelgeuse, might hold the key to solving some of these mysteries. Supernovae release an extraordinary amount of energy and radiation, which is crucial to understanding these phenomena. In addition, some researchers are of the opinion that these potent forces might interact with dark matter in ways that we could observe and investigate. One fascinating hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If there are WIMPs, the way they interact with the energy from Betelgeuse's supernova could tell us a lot about their nature. The first direct evidence of dark matter, a mysterious phenomenon that has baffled scientists for decades, would result from such a breakthrough. Similarly, Betelgeuse's explosion could offer insights into the nature of dark energy, the mysterious force driving the accelerated expansion of the universe by studying how light and energy behave during the supernova. In order to better understand how cosmic events like these affect the expansion of the universe and whether or not they are connected to dark energy, researchers may be able to gather crucial data. The upcoming explosion of Betelgeuse offers a unique perspective on the life cycle of massive stars, which play a crucial role in the cosmic ecosystem. Because red supergiants like Betelgeuse are uncommon, their study is crucial to comprehending the evolution of stars. These stars form from clouds of gas and dust that collapse under gravity, eventually igniting nuclear fusion in their cores. As they exhaust their hydrogen fuel, they expand dramatically, shedding their outer layers through powerful solar winds. This mass loss contributes to the enrichment of the interstellar medium, paving the way for the formation of new stars. In addition to providing insights into Betelgeuse's own life cycle, the supernova will also serve as a cosmic laboratory for studying the conditions under which stars live and die. Researchers will closely monitor the aftermath of the explosion to determine whether a neutron star or black hole forms at its core. The nature of this remnant will provide valuable information about the physical processes that govern the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. Additionally, the surrounding gas and dust will be heated and illuminated by the shock wave produced by the supernova. By analyzing the spectral signatures of these elements, this emitted light will provide astronomers with clues regarding the elements synthesized during the explosion, such as iron, nickel, and other heavy elements. We will gain a deeper understanding of how these elements travel through space and contribute to the formation of future stars and planetary systems by determining their abundance and distribution. Another area of interest is the potential for gravitational wave detection as the core collapses and the supernova unfolds. Gravitational waves carry information about the dynamics of the event, potentially providing new insights into the physics of supernovae and black hole formation. It may cause ripples in space-time that can be observed by observatories like LIGO and Virgo. The explosion of Betelgeuse might also spur technological advancements in astronomy. The anticipated influx of observational data will likely test the limits of existing astronomical instruments, which could result in real-time data, processing, and imaging technology innovations. Beyond the supernova, these innovations may be beneficial to a wide range of astrophysical research. Public engagement will play a crucial role in Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. This event can be used by educational programs, outreach initiatives, and citizen science projects to inspire the next generation of physicists and astronomers. Schools and universities may organize viewing parties, lectures, and discussions that emphasize the importance of understanding the cosmos and our place within it. As we prepare for this monumental event, excitement is building throughout the scientific community and among amateur enthusiasts. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, challenge our understanding of the universe, and unite us in our pursuit of knowledge. The death of a star becomes a profound reminder of the cycle of creation and destruction that defines the cosmos, urging us to reflect on our own existence and the mysteries that lie beyond.